Hello everyone, welcome back to the channel. In today's video, we're going to understand an important machine learning pre-processing technique called discretization, also known as binning. This topic is very useful when we are working with continuous numerical data whatever numerical data. It can be like age, fare, house prices, etc. Okay, so by the end of this video, what you will be understanding is like what is discretization, why do we use binning in machine learning, and what is KBinsDiscretizer? What are uniform, quantile, and KMeans strategies? And how this is applied on Titanic dataset, which I've used in this video using age and fare. Okay, so watch this video to the end because I will also explain some important exam points as well. Okay, so let's get started. Let's go on to the next slide. What is discretization? First, let's understand the basic meaning of discretization. In machine learning, we have often have continuous numerical values. Example is like we can have any example. We can take an example we have ages like 5, 12, 22 in this order. Okay, so these are exact continuous values. Now, instead of using exact values, what we can do is we can divide them into groups. For example, 0 to 10 can be child, 11 to 20 can be teen, 21 to 40 can be like adult. Okay, so this process of converting continuous values into groups or intervals is called like binning or discretization, any word will be fine. So in simple words, discretization means converting continuous numerical values into discrete bins or categories. Okay. Next comes the simple example, which is the type of age and after binning. Okay. Suppose we have a passenger. Let's take this example. Suppose we have a passenger whose age is 22. So instead of giving the model the exact value age is equal to 22, we can convert it into a bin. Like age group is equal to adult, or in machine learning format, age bin is equal to 2. Okay. Similarly, the ticket fares prices, like they are ticket fare prices of various, like it can be of railway, it can be of airline, or anything. Okay. So it can be converted into categories like low fare, medium fare, high fare. All bin numbers like 0, 1, 2, 3. Okay, so this makes the data simpler for some models to understand. Now comes why do we use binning? Okay, so now the question is why do we need binning? There's several reasons. First, binning can reduce noise. Okay, sometimes what happens is exact values are not very important. For example, age 21 and age 22 may behave almost similarly in dataset. Second, binning can reduce the effect of outliers. For example, like in the Titanic dataset I've used in this video, some passengers paid very high fares. Okay, if we use exact fare values, the model may be affected by those extreme values. But if we convert fares into bins, then the effect of outliers can reduce. Third is that binning can make patterns easier to understand. Instead of saying fare is 71.28 or something like that, we can say that passenger belongs to like very high fare group. Okay. Fourth, binning can improve the performance for some machine learning models, especially especially like tree-based model can sometimes work better when numerical features of them are like converted into meaningful groups. So the main purpose of binning is to convert continuous numerical features into similar groups so that model can learn better patterns from it. Okay. Next comes the dataset used in this video. So dataset, let me describe the dataset. So in this dataset, we have used the Titanic dataset, which mainly focuses, which is very famous. It is available across the internet. You can check that on the Kaggle as well as you can browse that on internet as well. Okay. So in this example, we will be using the Titanic dataset, which would be mainly focusing on three columns: age, fare, and survived. And age means like age of the passenger, fare, the ticket price paid by the passenger, and survived is like whether it survived the Titanic or not. Okay. And in the survive column, like zero means passenger did not survive and one means passenger survived. It's simple. Okay. So our aim is to predict the survival using the age and fare. Okay. So, uh, like here you can see x is equal to df of age, comma fare, and y is equal to df of survived. So this is the data frame we are using. Data frame is like data set we are preparing, in which one data set contains the age and fare, and another data set contains the survived. So x contains the input feature, y contains the output or target. So the model learns from age and fare and predicts whether the passenger survived or not. Okay, it's a basic pre-processing. So in this, what it involves is removing the missing values, and before training the model, we remove missing values. Okay, so this can be done through a code line, which I've written in the slide as well, and also in the notes. You can get the notes from the link below in the description. And yeah, so what this df dot drop any dot bracket of in place equal to true does, this removes rows where age of fair or survived is missing. So this is important because machine learning models cannot directly handle missing values. And the next part is train test split. In this, we divide the dataset into training and testing data. Okay, uh, in which we usually take that there is standard, like 80% data should be used for training and 20% data will be used for testing. The model learns from training data and then we check it performance on testing it. Okay, makes sense. Now comes the model before binning. So before applying binning, we first train a decision tree classifier on the original age and fair value. Okay, so this gives the the code which I've given below, like given on the screen, is which it gives the accuracy before discretization. So this is useful because later we can compare whether binning, whether the binning improved the model or not. Okay, so that's why we are using this. And when next part is what is KBinsDiscretizer. Now comes the main part. This is the title of the video, and here comes the main part. Okay. In Scikit-Learn, we used a class called KBinsDiscretizer. It is used to convert continuous numerical features into bins. For example, the code which I've given, this means we are converting the age column into 15 bins. Okay, let's say you have KBins, like you can get that the sample code in the notes as well. I'm attaching the link in the description, so you can just check out the notes. They are very good and they are available for free. So don't forget to check it out. The code is all there. So the code in that code, KBin is equal to we are converting the age column into 15 bins. Okay, and there is also a code for fair column in which we are converting the fair column into 15 bins. So that is the start. Okay. Next comes the meaning of parameters. Okay. So let's understand the parameters. First is the n bins. N bins, this will feature like this means the feature will be divided into how many groups. Okay. For example, if we use 5 bins for age, then age will be divided into groups, 5 groups, etc. Second comes the encode. Encode means each bin will be implemented using numbers, so the transfer output becomes numeric, and this will tell the type of encoding, like ordinal encoding, label encoding, or OHE encoding. Okay, one hot encoding. Next on the strategy. Strategy maybe decides how bins are created. Like in this example, which I've used in the notes, that contains how bins are created. So it contains quantile. Sorry, so strategy is quantile. And in quantile strategy, what we do is each bin contains almost same number of data points. For example, if we have 100 data points and 5 bins, then each bin will contain around 20 data points. So this is useful when data is skewed. Okay. And then comes the binning strategies. They are okay. So there are 3 important strategies. Basically, uniform, quantile, and K-means. So in uniform strategy, we create equal width bins. For example, like the age example only. If the age ranges from 0 to 100, and we create 5 bins, then each bin will have width of 20. 0 to 20, 20 to 40, similar like that. Okay. And what's the formula for that? Bin width is, you can get the formula and notes. I'm again saying notes are very important. You can check it out in the link given in the description below. I would be attaching the notes link as in the notes link in the comment as well. So don't forget to check it out. So the bin width is like max value minus min value divided by the number of bins. So uniform strategy is simple. but it may not work as well if the data is very highly skewed. Okay. Quantile strategy, what it does is it creates bins with almost equal number of data points. For example, if there are 100 samples in 5 bins, then each sample will contain around 20 samples. Okay. This is useful when values are not evenly distributed. Okay. So, for example, if most passengers paid low fare and what you can say is only a few paid very high fare. So the quantile binning can handle this better. Get it? Then comes the K-means strategy. K-means strategy creates bins based on clusters, if groups values like they're close to each other. Okay, you have read that in ML, but I'm still, and since it's a descriptive video, so I'm telling you like from the basic. Like if there are many groups, so you can and their values are close to each other, then we can make clusters, K clusters from them and do the ML part on it. Okay, so this strategy is very useful when the data naturally forms groups. Okay, then comes the column transfer. Column transfer is very important. You don't have to miss it, and we need to apply binning to both age and fear. Okay, so for that we have to use column transfer. This sample code which I've written on the screen is applied to like KBin age is applied to column 0, which is age, and KBin fear is applied to column 1, which is fear. So both columns are transformed separately. And if you want to dive deeper into the column transfer, you can just search that on internet or ChatGPT or anywhere, and like gain knowledge from it. But I think you don't have to go that much into the depth of it because column transfer is like simple. You don't have to do the messy stuff like traditionally that we do. It just does it in one line or something, like in one function. Okay. Next comes the fit transform and fit transform versus transform. So now we apply the transformation, and this is very important. We use fit transform on training data. Why? Because the transformer learns the bin boundaries from training data and also transforms it. Then we use only transform on test data because test data should not be used to learn anything. It should be only transformed using the boundaries learned from training data. So remember, training data, whenever we are using training data, uh, we use fit transform. And whenever we're using testing data, we use transform. So this prevents the data leakage. Okay. Next comes the checking bin edges. So after applying the binning, we can check the actual bin boundaries using trf.name transform. Let's say age or fare, whatever you are using, dot bin edges. So what this does is bin edges tells us the actual ranges of the bins. For example, age bin edges may look like 0, 12, 18, 25, 35, 50, 80. So this means the bins are like 0 to 12, 12 to 18, 18 to 25, 25 to 35, and similar like that. Okay, so bin edges, what it does, it helps us to understand how the data was divided. Okay, moving on to the next slide, model after binning. Now we train model after binning. Okay, so it's related to, okay, makes sense. So now what we do, now we have trained the decision tree model again, and but this time what we'll be doing is, while training the decision tree model again, we will be like using the transform bin data. Okay, so this code which I have given you in the screen, what it does is it compares the accuracy with the earlier accuracy. Okay, so if accuracy improves, binning helped. If accuracy decreases, then binning was not useful. So preprocessing techniques should always be tested and not blindly applied. Okay, and this code, sorry, my bad. I actually said it transforms. Sorry, yeah, sorry. I actually said it compares the accuracy, but it's not. I just said that by mistake. Okay. So, like this code is like for describes the model and then trains the model on that data set and compares, it predicts the output and then gives the accuracy. And then after that, we compare the accuracy with the earlier accuracy. Okay, moving on to the next slide. Next slide contains cross validation. So to get a more reliable performance score, we use cross validation. So this means like let's take an example. Like the example which I've given on the slide is like we have tenfold cross validation set, and like data set is one, but we are dividing it to 10 parts, and the model is trained and tested 10 times. Uh, and each time there's a different part. Different part is used for testing, and finally we take the average of the accuracy, and this what helps this gives a better idea of model performance than a single train test split. So moving on to the next slide, which is the important correction. So one important point, if you're predicting the survival, then your features and target should be like x is equal to input features be like age and fear, and output features be like survive, as I was discussed in the starting. But we should not indirectly or accidentally write like x is equal to df.iloc colon 1 colon or something like that, because that would mean you are predicting age using fair and survived, which is not the correct setup for survival prediction. Okay, so always identify the input features and output features and then do anything. Then comes a quick revision part. Let's quickly revise everything. First of all, what is discretization? So it's the summary of whatever I've told in the beginning. So if you are there from the start, you can skip this part and just check out the notes in the comments or description. And so if you are just summarizing, if you want if you want me to summarize everything, so then let's quickly revise what is discretization. Discretization, it means like converting continuous values into bins. And KBinsDiscretizer, why it is used? It is used in scikit-learning for binning. And then comes the n bins. N bins. What does n bins denote? It denotes the number of bins. Encode, the encoding strategy, encoding used like ordinal, lateral, or one hot encoding. Strategy used. This creates the like uniform used. If the strategy is uniform, it creates equal width bins. If the strategy is quantile, then it creates equal frequency bins. And if the strategy is KMeans, it creates the cluster based bins. And fit transform and transform. Fit transform is used on training data. Transform is used on the testing data. And bin edges, what does that show? It shows the boundaries of bins. Okay. So that was the complete explanation of feature discretization or binning using KBinsDiscretizer. So this is the final summary. This is an important pre-processing technique because when you want to, especially when you want to convert continuous numerical feature into uniform groups, we use this technique. So if you found this video helpful, then please like the video, subscribe to the channel, and comment which channel topic you want next. Okay, thanks for watching. See you next.